Picture this. It is the first week of June in Kingfisher, Oklahoma. The sun is beating down, the humidity is climbing, and you are standing in your yard staring at a metal box that has betrayed you.
Yeah, that is definitely not a good feeling.
Right. Your air conditioner is like 12 years old.
Mhm.
It is running, technically, but it is just blowing mildly warm air through your vents. So you call a professional out to your house, and the diagnosis, a failed compressor.
Which is the single most expensive component inside that box.
Exactly. So the technician hands you two options. The quote to repair that compressor is $1,800.
Okay.
And the quote to replace the whole system, meaning the outdoor unit and the indoor coil, is $8,500.
Big ouch.
Yeah, big ouch. You are staring at these two numbers, sweating in your own living room, wondering what on earth you're supposed to do.
It is the ultimate homeowner dilemma. I mean, this plays out on a loop thousands of times every single summer.
It really does. So welcome to the deep dive. Today our mission is to decipher the exact decision framework you should use when faced with this dreaded repair or replace home maintenance dilemma.
Right, because it's not a simple choice.
No, it's not. And we are pulling directly from the field notes of a master HVAC technician with 45 years of experience running condemnation calls in central Oklahoma.
Wow, 45 years.
Yeah. We are mapping out the precise math, the physical science of how these machines actually operate, and, the hidden factors that most sales reps conveniently leave out of their pitch.
Well, to build a proper framework, we first have to demolish a piece of advice that dominates the internet.
Oh, yes.
If you search for an answer to this dilemma online, almost instantly, you will be told to use the 5,000 rule.
Right, the famous internet rule.
Yeah, it is presented as this flawless mathematical formula to solve your problem. You take the age of your unit and you multiply it by the cost of the repair.
Okay.
And if that number exceeds 5,000, you automatically replace the unit. If it is under, you repair it.
Okay, let's unpack this. Because if we run the numbers on our scenario, the unit is 12 years old.
Right.
The repair is $1,800. 12 times 1,800 is $21,600.
Which is way over 5,000.
Astronomically higher. So the internet consensus says you drop the $8,500 and replace the whole thing.
Exactly.
But applying this rule, it feels like buying a used car solely based on the number on the odometer without ever, popping the hood to see if there's actually an engine inside.
That is a perfect way to put it.
It's entirely one-dimensional. It ignores the actual mechanical condition of the system, the materials physically running through its lines, and honestly, what your personal plans are for living in that house.
Yeah, people crave simple math when they are stressed and facing a massive bill. But relying on the 5,000 rule is essentially making a major financial decision while blindfolded.
Right.
The age and the repair price are merely two variables in a much larger equation. To make an informed choice, the notes from our 45-year veteran indicate you have to look past the broken part itself.
Okay, so where do we look?
Step one is actually locating a small sticker on the side of the outdoor machine.
The data plate.
Yeah.
And specifically, what that plate tells us about the liquid gold pumping through the system, the refrigerant.
Yes, because in the year 2026, the specific type of refrigerant your system uses basically dictates your entire financial reality.
Wow, really?
Yeah. Because if you have a 12-year-old unit, there is a very high probability it uses a refrigerant called R22.
Okay, and what is the issue with that?
Well, the physical function of refrigerant is to act like a sponge, right? It absorbs heat from inside your house and carries it outside to release it. But R22 was officially phased out of production in 2020 due to environmental regulations.
Which means the supply chain completely dried up.
It did. The only R22 available today comes from the gray market. These are supplies that have been reclaimed from old units and recycled.
Oh, wow.
And because it is a finite, dwindling resource, the basic economics of supply and demand have pushed the price to anywhere from $90 to $150 per pound.
Per pound. And a standard 3-ton residential air conditioner doesn't run on just a tiny splash of the stuff, right?
Oh, not at all. A system that size holds somewhere between 7 to 9 pounds of refrigerant.
Jeez. So if your compressor failure also involved a leak, which I imagine is incredibly common.
Very common, yes.
Replacing the lost R22 alone could easily add $1,000 to your bill before the technician even picks up a wrench to fix the mechanical failure.
Exactly. You are paying a premium just to acquire a banned substance to keep a dying machine on life support.
It is exactly like owning an outdated printer, where a single replacement ink cartridge costs more than simply driving to the store and buying a brand new top-of-the-line printer.
That is exactly it. The sunk cost fallacy traps people, but it makes zero economic sense to keep feeding it.
Right. So if your data plate says R22 and you have a major failure on a 12-year-old system, the debate is effectively over. It is an automatic replacement.
Yes. However, if you look at that data plate and it says R410A, the landscape shifts entirely.
Right, because R410A is currently the standard, widely available refrigerant.
Exactly. It hasn't hit those massive gray market price spikes. So in that scenario, paying for a repair remains a mathematically viable option.
And just to cover all our bases from the source material, there are also brand new, low global warming potential refrigerants hitting the market, designated as R454 or R32.
Right, but those only started shipping in 2025.
So if you see those numbers on your data plate, your unit is practically brand new out of the box. You shouldn't be facing a 12-year repair or replace dilemma in the first place.
Exactly. So the refrigerant type gives us a definitive green light or red light.
Okay.
Assuming we have the green light of R410A, we can consider a repair, but assessing the metal box in your yard is only looking at half the equation.
Here's where it gets really interesting. Because the biggest financial disasters happen when people forget that the other half of the system is hiding inside the house.
Usually sitting right on top of your furnace in a dark closet or an attic.
Right, we have to examine the indoor coil.
The outdoor condenser is connected via copper lines to that indoor coil. And a common trap homeowners fall into is deciding to replace the broken outdoor unit, but leaving the 12-year-old indoor coil untouched to save a couple of $1,000s on the quote.
Which creates a catastrophic mechanical mismatch.
Oh, absolutely.
It's like dropping a brand new high-performance V8 engine into a car that still has its original rotting tires and a rusted-out transmission.
Yeah, it's not going to end well.
Right. The engine has all this incredible power and efficiency, but the rest of the vehicle simply cannot handle the output. The whole thing is going to tear itself apart.
That analogy holds up perfectly when you look at the physics of the indoor coil. That 12-year-old coil has been sitting in the dark, accumulating over a decade of microscopic dust.
Gross.
Yeah. And dust acts as a thermal insulator, which severely cripples the coil's ability to transfer heat. Even worse, the brazed copper joints on that coil have endured 12 long summers of thermal expansion.
Expanding when warm, contracting when freezing cold.
Exactly. Along with the constant vibration of the blower motor, the metal is heavily fatigued.
Not to mention the internal metering device.
Right. The metering device is basically the nozzle that controls the physical pressure of the liquid refrigerant entering the coil.
Yeah.
And the old device was specifically sized and calibrated for the old outdoor equipment.
So when you pair a powerful, modern outdoor compressor with a fatigued, dirty indoor coil and an outdated pressure nozzle, you basically guarantee that the entire system will struggle with pressure imbalances.
Yes. It will limp along, overwork the new compressor, and likely suffer a total system failure within 3 years.
Wow. But the nuance from our experts' notes is vital here. If you happen to be in a situation where that indoor coil was already replaced under warranty, say 4 years ago, then the math flips back.
It does. Suddenly, repairing the outdoor unit makes perfect sense because the indoor component is still fresh enough to handle the workload.
Okay, that makes sense.
Beyond the coil, there is another hidden variable in the attic that dictates the success of any HVAC investment, and that is the ductwork.
Oh, the ductwork.
Yeah. Our source material notes that in 45 years of running condemnation calls, the expert has witnessed countless homeowners spend $9,000 on ultra-efficient new equipment, completely ignoring the delivery system attached to it.
We were talking about collapse sections of flexible ducting, boots that have literally detached from the ceiling vents, or original metal trunk lines where the insulation rotted away decades ago.
Right, and when your ductwork is compromised like that, you can leak 25% of your perfectly conditioned, expensive cold air straight into a 140-degree attic.
You are quite literally paying top dollar to air condition your roof decking.
Exactly. Dropping $8,500 on a new AC unit in that environment is pouring water into a bucket with a massive hole in the bottom.
Yeah, that is pointless.
This is where a truly honest diagnostic approach changes the game. Often, the absolute smartest resource allocation is to spend the $1,800 to fix the compressor on the old AC, and then take $2,500 to completely overhaul, seal, and insulate your ductwork.
So for half the cost of a full system replacement, you buy yourself 4 more years of equipment life, but more importantly, you create a system that finally delivers actual cooling to your living room.
Exactly.
We get so hyper-focused on the shiny machine generating the cold air,
Right.
we completely forget about the physical pathways carrying it.
Right. So having diagnosed the hardware, the refrigerant, the coils, the ducts, we have to pivot to the person paying the invoice.
The human element.
Yes. The physical mechanics only matter in the context of the homeowner's personal timeline.
The question sales-focused technicians rarely ask. How long are you planning to stay in this house? Because your personal timeline completely alters the math.
It really does.
Let's look at the scenario where you were planning to sell the house next spring.
If a sale is imminent, dropping $8,500 on a brand new system is a poor investment.
But wait, I would assume a brand new AC unit increases the resale value of the home, though. Like, why not use it as a selling point?
You would think so, but it does not increase the value dollar for dollar.
Oh, really?
Yeah. The harsh reality of real estate transactions is that a prospective buyer will order a home inspection, see an older unit, even a working one, and immediately try to negotiate a credit or a price reduction anyway.
Ah, that makes sense.
So if you spend the $8,500 up front, you are purchasing a 15-year mechanical asset that you will only benefit from for a few months. You will not recoup that cash at closing.
Right.
The strategic move is the cheapest, honest fix.
So pay the $1,800 to repair the compressor, get the system running smoothly to survive a summer of open houses.
Yes.
Disclose the repair cleanly on the seller's disclosure, and let the new buyer decide how they want to upgrade the home once they take possession.
Exactly. Conversely, we must look at the forever home scenario.
Okay, so like a 55-year-old couple, empty nesters who have no intention of moving for the next 2 decades.
Right. In that specific timeline, the math heavily favors the $8,500 replacement.
Because over a 12 to 15-year horizon, a new system genuinely pays for itself through efficiency gains.
It does.
Let's break down that efficiency math because, well, it pays for itself is the ultimate salesman cliche. We need to define the actual return on investment.
We measure this using the SEER rating, the Seasonal Energy Efficiency Ratio. Think of it as the miles per gallon rating for your house.
Okay.
A 12-year-old unit is likely operating around a 13 SEER rating. If you replace it with a modern 16 SEER variable speed system, that new unit will operate roughly 20 to 30% more efficiently.
Okay, so if we take a standard $200 a month summer electric bill, a 20 to 30% reduction saves roughly $40 to $60 a month.
Right.
And over a typical 5-month cooling season, you're keeping $200 to $300 a year in your pocket. Multiply that annual savings by the 12-year lifespan of the new unit, and you're looking at $2,400 to $3,600 in pure energy savings, offsetting the initial purchase price.
That is the direct financial return. But there's a secondary benefit to modern efficiency that numbers fail to capture, and that is the physical comfort upgrade.
Okay, I have to push back a bit on that.
Sure.
Besides saving a few $100 a year, what does efficiency actually feel like? From a sensory perspective, cold air is cold air. Why should I care if the unit is high efficiency or variable speed as long as it drops the room temperature to 72 degrees?
Because treating air is not just about manipulating temperature, it's about managing humidity.
Ah,
Yeah. An older single-stage unit operates like a light switch. It is either 100% on or completely off. It blasts cold air at maximum capacity, cools the room very rapidly, and then shuts down.
resulting in that clammy cold cave feeling where the air is chilly but still feels heavy?
Precisely, because the cycle was so short, the machine didn't run long enough to pull the moisture out of the air.
I see.
A modern variable speed system operates more like a dimmer switch. It runs for much longer, slower cycles at a lower capacity. The mechanism of dehumidification relies on air constantly moving over a freezing cold coil. So by maintaining a slow, steady jog rather than a full sprint, the system continuously pulls the deep humidity out of the house.
And because drier air allows the moisture on your skin to evaporate more easily, your body naturally cools itself better.
Which means you can actually set your thermostat 2 degrees warmer, setting it 74 instead of 72, and physically feel significantly more comfortable.
Wow.
You are saving money on the mechanical efficiency of the machine, and you are saving money by raising the thermostat, all while upgrading your daily comfort.
That dual-layered savings makes a very compelling case for replacement. So we have mapped out the traditional repair path and the traditional replace path.
Yes.
But reading through these field notes reveals a secret menu option,
Yes, a third path that the vast majority of homeowners don't even know exists.
a rebuild option.
Right. In the trade, it's often referred to as a rehab.
Okay, so what does a rehab actually entail?
Well, if the existing unit has solid bones, meaning the exterior metal cabinet is structurally sound, and it's built on a reliable conventional platform or is a high-quality geothermal unit.
Okay, so if the foundation is good.
Exactly. A master technician can perform a complete mechanical overhaul for about $3,500 to $5,500 installed.
Let's define the mechanics of that overhaul. What specific parts are being swapped out for that price?
They strip it down to the chassis, they pull out the dead compressor, which is the heavy-duty pump that squeezes the refrigerant gas to raise its pressure.
Right.
They replace the entire indoor coil we discussed earlier. They install a new metering device, which is the mechanism that creates the pressure drop.
Okay.
They replace the contactor, which acts as a giant industrial light switch clicking the high voltage on and off. And they replace the capacitor, which functions as a heavy-duty battery jump starter, giving the motor its initial kick.
It sounds like they're replacing literally every moving part.
Pretty much.
But I have to ask, by just swapping out internal organs on an old frame, aren't you just Frankensteining a machine together to buy a few months of borrowed time?
Not if it is done properly, which requires a critical final step: pulling a deep vacuum on the lines.
A deep vacuum.
Yes. When a compressor burns out, it often leaves moisture and non-condensable gases inside the copper piping. If a technician just bolts on a new compressor and fills it up, that leftover moisture mixes with the refrigerant oil to create a highly corrosive acid.
An acid that literally eats the new machine from the inside out.
Exactly the fate we want to avoid. A master technician uses a specialized vacuum pump to suck every microscopic molecule of moisture and gas out of those lines before recharging the system to factory specifications.
Wow.
A thorough rebuild like this extends the life of the unit by 8 to 10 years. It comes with a 1 to 2 year parts and labor warranty for conventional systems and up to 5 years for geothermal systems, assuming the underground loop verifies as fully functional.
So if this rebuild option saves a homeowner thousands of dollars compared to a $15,000 full system replacement, and it secures an entire decade of warranted life.
Yeah.
Why isn't this the default recommendation? Why aren't contractors shouting about this option?
It comes down to the brutal economic reality of the HVAC industry, profit margins and labor scaling.
Of course.
Most contracting businesses will never offer the rebuild option because the profit margin on a $4,500 rebuild is remarkably lower than the margin on a $15,000 total replacement.
That makes sense from a business standpoint, unfortunately.
Furthermore, rebuilding a system requires a highly skilled technician who understands complex diagnostics, brazing, and vacuum physics. Taking an old box out and sliding a new box in requires much less specialized training and can be done faster.
Right.
A technician only offers the rebuild path if they are genuinely prioritizing the optimal solution for the homeowner's specific house over their own company's quarterly revenue targets.
It really highlights the value of finding a master technician who operates as an advisor rather than a quota-driven salesperson.
Absolutely.
Which brings us to the final layer of this decision framework, and it is incredibly specific to the financial landscape of 2026.
Right, because the macroeconomic landscape changed significantly recently.
So if you bypass the repair and the rebuild and decide to replace your system with top-tier technology like geothermal, you have to navigate the shifting reality of rebates.
Yes. If a salesperson is sitting at your kitchen table pitching a highly efficient geothermal installation, and their math relies on the federal Section 25D tax credit to make it affordable,
you need to recognize that as a massive red flag.
Because the federal well ran dry.
Right.
That federal tax credit officially expires on December 31st, 2025. It simply does not exist for a 2026 installation. Any pitch relying on expired tax law is either deeply uninformed or actively deceptive.
So with the federal money gone, does that mean high-end, hyper-efficient systems are just completely out of reach for the average homeowner now?
Not necessarily, but you have to shift your focus from the federal government to your local utility providers. In central Oklahoma, local grids are offering massive incentives. Seek Energy, for example, is paying an astonishing $2,000 per ton, up to $24,000 total, for geothermal installations.
Wow.
OG&E is paying $1,000 per ton, plus an additional $1,500 per unit. Cimarron Electric is offering $600.
Let me do the math on that. If you install a standard 4-ton geothermal system, Seek Energy is literally writing a check for $8,000 to offset the cost.
They are.
Why would a utility company hand out that much cash just to help me cool my house?
It is a matter of grid load management. On a 105-degree August afternoon, conventional air conditioners draw massive amounts of electricity, straining the grid to its absolute limits.
Right.
To handle that peak demand, utility companies would normally have to spend billions of dollars building new peaker power plants. Geothermal systems use the stable temperature of the earth to cool your home, drawing a fraction of the electricity.
Oh, I see.
It is significantly cheaper for the utility company to pay you $8,000 to reduce your load than it is for them to build a new power plant.
That makes perfect macroeconomic sense. And for the homeowner, it completely changes the calculus.
Completely.
That local rebate can turn a terrifying $25,000 geothermal quote into a $13,000 to $15,000 net cost.
Exactly.
Suddenly, installing the absolute top-tier, most efficient technology on the market is financially competitive with a standard conventional AC replacement.
But you only unlock that financial reality if you know to look locally instead of federally.
So what does this all mean? Let's bring this entire framework together.
Okay.
You are standing in your yard in Kingfisher, Oklahoma. It is June. The air conditioner is blowing high.
And you are holding that $1,800 repair quote and that $8,500 replacement quote.
Right. It means you permanently discard the 5,000 rule.
Yes. It is a mathematical blindfold that ignores the physical reality of the machine.
The actual decision matrix is a 5-step checklist. Step 1, check your data plate for the refrigerant type. The R22 phase-out means replace, while R410A means repair is financially viable. Step 2, look at the age and condition of the indoor coil. Do not attach a powerful new outdoor unit to a fatigued, dust-choked indoor coil with an outdated metering device.
Exactly.
Step 3, inspect the attic. Do not hook up a brand new, ultra-efficient system to compromise ductwork that leaks a quarter of your purchase comfort into the roof decking.
And step 4, be ruthlessly honest about your personal moving timeline. Are you selling next year, or is this the forever home?
Right, because that answer dictates whether the long-term energy efficiency and the physical comfort of a variable speed dehumidification cycle will actually pay you back.
Exactly.
And step 5, ask your technician about the secret menu. Ask if the chassis and bones of the unit are solid enough for a complete mechanical rebuild.
And if a full replacement is the only logical path, hunt down those 2026 local utility grid rebates, because the federal tax credits are a thing of the past.
This level of transparent, highly customized mechanical analysis is exactly why the source we pulled from today, that 45-year master HVAC veteran in Oklahoma, maintains a 4.8-star rating across nearly 300 reviews.
It really comes down to offering honest diagnostics based on physics and economics.
Right. Charging a straightforward $99 dispatch fee and a $111 diagnostic fee, rather than using a burned-out compressor as leverage to push the highest margin replacement possible.
Yeah.
It is the profound difference between being sold to and being advised. It's taking the time to understand how the components interact, rather than just staring at the age of the machine and panicking.
It really is a completely different approach to problem solving. And stepping back from the immediate topic of air conditioners, this entire conversation leaves me with a thought I can't quite shake.
Oh, what is that?
Well, we have just dissected how a generic rule of thumb almost tricks us into throwing away complex machinery that might simply need a strategic component overhaul or a ductwork seal.
Right. A completely unnecessary waste of resources based on a catchy formula.
Exactly. It makes you wonder how many other expensive, complex systems in our lives, our homes, or even our businesses are we entirely replacing out of habit, just because some industry rule of thumb told us it was the standard timeline, without us ever pausing to understand the mechanisms, look deeper, and see if the bones were actually still good.
That is a fascinating, slightly uncomfortable question to leave on. Thank you so much for joining us on this deep dive. We will catch you next time.